Hello and welcome back to yet another project on deep learning. This time I have decided to use a sequential dataset. So thereby we'll be using recurrent neural network. We have a dataset in which we have the alcohol cells starting from January 1992 to January 2019. Our task is to build a recurrent neural network such that it can predict or forecast the alcohol cell in the next 1 year. So with this in mind, let us get going and see what the project is all about. Okay, so let us get going. Before starting this project, be sure that you are running this notebook in the same folder where you have placed your dataset. The dataset, that is CSV file, you have to put that in the same folder wherever you are running your notebook in your computer. Let me start with importing some of the libraries. So I'll start with importing Torch. This imports PyTorch library, again deep learning framework that is used for building and training the RNN model. Then torch.nn as nn, import numpy snp, import pandas spd, import matplotlib .pyplot as plt. This is pandas. So these are the library that we have imported, and now let me import the dataset, that is df equal to pd.read_csv and then the name of the file. So you have to make sure that you are placing this file in the same folder wherever you are running this notebook. If you do not do that, you just have to mention the path of that particular file and then it will do the job for you. So you can see that there are just two columns. It's a sequential dataset that is starting from I think 1992 to 2019. So 325 rows. Apparently it's a, I think it's a monthly dataset that we have in this here. So you have, one is the date and another one is the alcohol cells, which is in millions of dollar monthly from January 1992 to January 2019. Right away, our first job is to make sure that the column type is correct, which is not, because if you see the date type here, it is object, which is a string. So what you have to do is we have to convert this date column from string format to date time format, and this is being done by pd dot to date time df date, and then you assign this back to df date. Check your df.info now. You can see it is date time format now. Okay, then you you have to verify that if it is, everything is fine here. So that you can again do if you want to, then you can just fix that. You can say that df date dot index location 0. So you can see it is a timestamp over here. Okay, now what I'm going to do is I'm going to set the date as index. So I'll say df dot set index and then mention the column name, which is date, and I'll say if you just run this as it is, there we go. I'm going to assign this back to df. This is how it works. Now let us try to visualize this. Let us try to plot this out, how it works in just time series format. So I'll say this is plotting time series data. So I'll say plt dot figure, fixed size I have to define, happens to be 12 by 4. Now I'll say plt dot title, this is whatever, alcohol cells. Then I'll say plt dot y label, this is cells in millions of dollars. Then plt dot y grid, I'll set that as true as well. Not y grid, it is just grid here. Then I'll say plt dot plot, the thing that I'm going to plotting, that is df, and the column name, which is whatever the column name is, s4 2 and whatever. And also say plt dot show. So this is what you're getting. You can see starting from 1992 to 2019, it is more or less going upwards, but you can say it's a periodical data set. Maybe month wise there's a decrease in cells and a increase in cells of the alcohol and so on and so forth, which is again very much understandable. Okay, next is to prepare the data for training. We'll go into the train test sets, then we'll also have to normalize the training value so that they fall between -1 and 1, so that we can so as to improve the training. So I'll start with extracting the values from .csv file. That is, I'll say df s whatever this is, and I'll say dot values, and I'll also define type here, floating type. Sorry, you have to not add this single quote, run that, there we go. Right, so this is y value. Then you define test size as 12. All right, you can define anything else as well. I'm just trying 12 so that we can just predict the 1 year in advance, but you can put some other size as well, that depends on you. Then I'm going to say trend set is y, get me everything up to test size, and test size is y minus test size. Sorry, this is not test size, this is test set. That is going to give me everything from this. So test set, you can see it is over here. Alright, so you can see that this is what we are getting, the tensor. Next step is to normalize the data. So I'll be using min-max scaler in this. I'll say from sklearn dot preprocessing import min-max scaler, right? Then I'll say sc is equal to min-max scaler, but I'll just make one change here, that is the usual range is 0 to 1 in min-max scaler, but instead of 0 to 1 I'll put -1 to 1, so that I can take 0 as the kind of a median of everything. So you can put 0 and 1 as well, but for this one I'm taking -1 and 1. Then I'm going to normalize the training set, sc dot fit underscore transform train set. But train set, if you run this, it is actually this, which is a one-dimensional array. What I'm going to do is try to reshape this and say -1 to 1. I'll just try to flatten this out, so this becomes a two-dimensional data set. Alright, so this is what I'm going to take. I'm going to copy this and put it over here. So when you run that, this is what you're getting, a two-dimensional data set, which is, I'm going to say scaled, not scaled, I'll say train normal. Now just to be clear, if you see train normal and find the minimum value, that is going to be 0. If you take train normal, if you take the maximum value, that is 1. If you take train normal one more time and say what is the mean, that is around -2. Okay, so this is what we are getting. Now what you have to do is we have to now prepare the data for LSTM. I'll start with converting train norm from an array to a tensor, right? Again, I don't have to explain this. We are having array at this point. We have to convert that into a tensor. So I'll say train normal is equal to torch dot float tensor, then train normal dot view as -1. Then I'm going to define window size. So that is going to be window size. I'm keeping that as 12. Next is to define a function to create sequence label tuples. So that is going to take input data sequence comma window size. WS is the window size here. Then output is some empty list. L is length of the sequence. Then for I in range, L minus WS, it is window is equal to sequence I plus WS, I to I plus WS, right? Then this is sequence, and label is going to be sequence I plus WS, I plus WS plus 1. Then you take that output and append it and say window comma label that you have got. And lastly, you'll have to return the output. Now we have to apply this input data function to my train norm, the variable that I've created. So I'll say input data, that is going to be train norm comma window size. This is run that. You can see this is what I'm getting, where the first one is the this entire thing, this basically is a training data here. So I'm going to assign this over here to train data. All right, so train data is here, but if you check the length of this is 301. Why 301? The very simple reason, 325 rows where window size is 12 and last 12 we cannot get because it's a sequential data, thereby 301. As I explained, the train data, it is actually a sequence of two things. It's a tensor of two things. One is sequence and second one is the label. So this is, if I try to put maybe 0 here, it will be much more clear. So this is sequence and this is the label. All right, great. Now what I have to do is we have to define the model. So I'll say class LSTM network I'm creating, that is going to inherit everything from nn.module, and I'm creating a constructor def __init self comma input size is equal to 1, hidden size is equal to 1. output size is equal to 1 again. Then it is going to use super to grab and get everything from the parent class. Super dot underscore underscore init underscore underscore, this is dot, and then we have this parenthesis. Let's say self dot hidden size is hidden size. Then I'm going to add LSTM layer to this, which is self dot LSTM is equal to NN dot LSTM. That is going to take input size and hidden size. Then I'm going to add a fully connected layer. Fully connected layer is going to be self dot linear is equal to NN dot linear is going to have hidden size comma output size. Then we are going to initialize h0 and c0. Self dot hidden, then torch dot zeros 1 comma 1 comma self dot hidden size, and one more torch dot zeros, that is going to be 1 comma 1 self dot hidden size. Then a forward pass def forward self comma sequence, and that is LSTM out comma self dot hidden is equal to LSTM self dot LSTM, and here you have to define the input size, that would be sequence dot view, that is going to say length of sequence comma 1 comma -1, then self dot hidden here, and lastly we'll have the pred is equal to self dot linear, that is going to have LSTM dot view, that is going to be length of sequence comma -1, and lastly I'm going to return pred as -1 because we only want the last value. I hope everything works fine here. Yeah, it has worked quite well. Next is to instantiate the model. Instantiate the model, and also we will define the loss. We will also define the optimization functions. So torch dot manual seed, then any number, any seed that you want to enter, then model is equal to LSTM network, and criterion is going to be, since again it's a continuous value that you are predicting, so that is I'm taking MSC loss. Optimizer, you can choose I'll choose Adam optimizer for this one. Then model dot parameters learning rate is equal to 0.01, and here on that model Okay, there's some problem. Let me check this one more time. This is, yeah, there is this size here. There you go. Now it should work. So model is this. So if you check the model that we have created, you can see that we have one feature input, one feature output. This should be 100 actually. Why this is 1? Have we kept input size as 1? Actually, we have not kept hidden size as 100. That is why I'm getting this. Hidden size is 100. Alright, so run this one more time. Everything. There you go. Now it is fine. Okay. Now, if you want to count the parameter, you can do that as well. You will say simply params, and that is going to be equal to p dot number of element for p in model dot parameters if p dot requires grad. Then I'm going to take this list that I've created and say for every item in the parameters, I just want to print that parameter f literal curly bracket item is greater than 6. There we go. So these are the number of parameters that you're getting. This is around, I would say, 41,301. These are the number of parameters that you're getting. Next is to train our model. So let us do that. So train the model here. So I'll say epochs. Define any epoch. I'm putting 100 because again it's a tabular data. It should be really easy for us. I'm going to import the time just to keep track of time, how much the time is taken to train our model. So time is here. Then I'll say for epoch in range epochs, I'm going to extract sequence and label from train data. Train underscore data. All right, I hope we have train data somewhere. Yeah, we have it. So this is in definitely for sequence and ytrain in train data. I'm going to say first reset the parameter, then I'll say model dot hidden is equal to torch dot zeros 1,1 dot model dot hidden size torch dot zeros 1,1 dot model dot hidden size. Then ypred is equal to model, pass the sequence, and that will give me the predictions. Calculate the loss. It is criterion ypred ytrain. This is training losses, by the way. Then loss dot backpropagation backward. Then optimizer dot step is here. Then print the training result. That is going to be print f literal epochs is going to be epoch curly braces epoch plus 1 to 2, and this is loss dot item. Then this is 10 point maybe 8f. There you go. And at the front I'll say print f literal backslash n maybe one more \n, that is going to give me the duration of the training. Duration would be time minus start time, that is 0.0 f seconds. There you go. Okay, there's some problem here. This is invalid decimal literal in time. Yeah, this is causing the issue. There we go. Let it run. Alright, so it has finished training, and it took me, and at my end it took 38 seconds, which is good news. Now I'll go through the prediction ones, and then I'll try to explain everything that we have done so far. So I'll say predictions and comparison to known test data rather. So I'll say I want to predict for future 12 months, that is 1 year, and I'm going to add a window of training values to the list of prediction. So preds is equal to train norm, that is minus window size, then dot to list. Right, then I'm going to set the model to evaluation mode. Alright, model.eval, then I'll say for index in range of future. So for each of the next 12 values, I want to get the sequence using preds, that is going to be minus window size, and this I have to convert to tensor. So I'll say torch dot float tensor is here. Then I'll say with torch dot no grad, this is torch dot hidden is equal to torch dot zeros, this is 1 comma 1 comma model dot hidden size comma torch dot zeros 1 comma 1 dot model dot hidden size. Then this is preds dot hidden, this is append. Then I want to take the model dot sequence, then dot item here. Right, I hope we got it right. Let me check the preds and take the window size and get everything. So this is there. Alright, by the way, this is equivalent to preds and minus future, the same as the last one, that is the window size. So this is going to be minus 12 and grab everything else, and this one is there. So this is what we have done so far. Alright, great. Now what we have to do next is we have to invert the normalization. We want to compare our test predictions to the original data. So this is normalized value. What we have to do is we have to, since we have done previously the normalization step, now what we have to do is we have to do the inverse transform, inverse of normalization, just opposite to what we have done. So for that, and I'll mention this specifically, this is important rather, invert the normalization, right? So this is scalar dot inverse transform, and it is going to be np.array is going to be breadth window size is here dot reshape -1 comma 1. We run that, there you go. So now these are the true prediction of the value. So these are true predictions. All right, so now what you have to do is we have to, maybe we can just compare this. The true values that we got are this, isn't it? And the the predicted value that we got are this, but the true values, if you check that, right, that is -12. You can see this is what I mean. So my predicted value is 9778. This is 10414. This 10180. But the true value is this, and so on and so forth. So this is how it works. So our prediction, it looks like that we're not far off here. Now before I plot the what we have got and what is the true value, let me just go back and just go back and try to explain what we have done so far. So we started from the very beginning, that is we have read the dataset. All right, so this is importing all the libraries, the torch, numpy, pandas, matplotlib. Then we read the dataset, we have change the data type of date to date time. Then we plotted the alcohol cells versus this, so that it is giving me kind of a idea that what this is doing. Then I prepared the data using this. So for that I have defined the test size, what is the test size that I want, and using that test size I'll have the training set and the test set. Okay, so this is how it works. So test size, it reserves basically the last month, starting from February 2018 to January 2019, and training set, it will create that. So this will be 325 -12 that is 301. But this is all well. However, to create this data, we have defined this input data here. This is going to create this one, right? You can see yeah, this is what I was talking about, 301 here, right? So this one, it is looping through the sequence, creating the windows. It is a sequence of windows value, ws values. The next value is being defined here using this label after the window, and this is adding the tuple to the list. And lastly, we have returned the list of the tuples. And here, this is what you got. There you go, right? So this is sequence label pair. All right, then this is the model. We have inherited everything from the NN module. We have defined the input size, hidden size, and output size, and then we have defined the added the LSTM layer, fully connected layer, and initialized our H0 and C0. Thereby I am getting some prediction. Then I create the instance of the model, criterion of the model, optimizer, which I'll be using to train my model. Here, this is what I've done to train my model, and at the end I got this loss, and that took me 38 seconds. Then I went ahead and predicted the last 12 basically the last year of my dataset, which I'm now trying to compare to the true result. So I'm going to plot the result here. This is, I'll say, I'll define x here. X is np.arrange from 2018 0201 to 2019 0201, and I have to mention the data type here. Data type is date time 64 RNN dot as type, and this is date time 64T. Looks okay to me. This should not be here, definitely, because this should be here. Okay, check your X here. There you go. So this is the array that I have created. Why we have created this, we'll see in a moment. So what I'm going to do is I'm going to say plt.figure will have fixed size as 12 by 4. plt.title. In fact, you know what I'll do is I'll just do a copy paste here, because it's the same figure that we'll be plotting, just one difference. I'll copy and paste it over here. Okay, so there you go. Now we are going to plot x comma true predictions. We plot that. You see, this is what I'm getting, which is not at all good. Let me check this here one more time. This is x comma true predictions, and true predictions is coming from this. Have you got everything right? Well, not entirely, because it should go up and down, right? So let us see what are the changes that we can make. Okay, first of all, this has to be model, definitely. Run this one more time. In fact, we have to run everything one more time. Yeah, now it is doing better. You can see this is, you know, much more following the trend. But this is not actually clear. So what I'm going to do is I'm going to just select a part of the graph that is relevant for me. So I'll copy this as it is and just mention some of the things. I'll say that this is I'll put some space here, and then this is plt dot auto scale. Axis is x, type is true. All right, then figure dot auto format x date. Okay, you can skip this if it is not working. Right, just run this as it is. There you go. And a few more things I have to mention here, that I'm not going to plot everything. I will plot from 2017 01 01. So I'm plotting from first basically January 2017 to onwards, so that we can have this plot basically. So you can see that the orange one, it is the predicted value, and the blue one, it is the true value. It is following the trend, although there's some difference here, but it is, you can see it is going up with this blue line, it is going down with this blue line. However, there's some difference in the exact nature. Great, but this is on the known data. How about forecast? So I'm forecasting into an unknown future. So based on the sales value of last 30 years, about 30 years or 25 years at least, I'm going to predict the future of next 1 year. That is what I'm trying to do. So for that, I'm going to In fact, I'll do one thing. I'll copy this from here. This entire thing I'll copy and make some changes. Right. So this time I'm saying that model dot train. What this means, we are setting the model back to the training mode because earlier it was in evaluation mode. Then I'm going to feature scale the entire data set. So I'm saying y norm is equal to scale dot fit transform y dot shape y dot reshape. This is -1, comma 1. Then y norm is equal to torch dot float tensor. That is y norm dot view, then -1. Then I'm saying basically all of my data, I'm passing that into the function that I created, that is the input data, which is going to have y norm and window size of 40. Rest of things, it is more or less it is going to remain the same. I'll just make the changes wherever it is required. This is no longer a training data, it is all of the data. And yeah, that's it. I think rest of things is fine. All right, so let me train on my entirety of the data now. Okay, so it took me again 38 seconds to train my model. Now I'm going to copy one more thing. I'm going to copy this thing here. Copy this, come down, and what we are doing now, it is we are trying to predict the future values, and we are also going to plot the result. So this is what we have. I'm going to make some values here, some variables. This is window size. I'm putting that as 12. I'm saying L is equal to length of y. Great. Then model.eval, it is going to remain the same. Range is future, everything is fine here. Sequence is as it is, no changes here as well. This is going to reset the hidden parameter and it's going to upload the model. Next, what you have to do is copy the inverse normalization. So I'll copy this one more time, come down, and in the same cell I'll say that sc dot inverse normalization, this is spread and not a window size here. No, it is not required. So window size, that's it. np dot array and pred, that's it. All right, this is sc normal np, yeah, great. Next is to set here x here, and this time I'm taking this entire thing, just one difference. The difference is that I'm not taking from 18 and taking this from 19 because I want to predict the future, right? I already have the data set up to January 19. I'm predicting in from February 19 to January 2020. So this is what we have. Then I'm going to take the plotting over here, copy this as it is, come down, then this is, I think everything is correct here, no changes at all. Predictions, and this is going to be window size over here. There you go. There it is. You can see it is now predicting the future cells of my alcohol. Right, let me just fix some more things here. I'll just copy this one more time and just say that I do not want everything. I want from 2018 0101 to the right of it. There we go. So you can see that this is my cells data going forward. Our dataset was up to this point. Now there's a break here because it is a discontinuity at this point in January 2019. But you did not worry about this because it is from remember my plot. It is up to 1st January 2019, but my prediction it is from 1st of February 2019, and thereby we have this kind of a gap between the 1st of January and 1st of February. That is the reason that these two things are not connected. Anyway, so this is the prediction of my alcohol cells go in the next 1 year. Again, going back in the time I'm taking, this not updated data set, but if we had up to obviously 2025 at the time of today, then we would have predicted in 2026. Okay, so this is it for this particular project. Well, I hope you enjoyed this particular project. It was a really fun project for me as well. We have successfully forecasted the cell from February 2019 to January 2020. That is 12 months, 1 year. So that's a good news. Know that it was a rather a simpler dataset where we are just trying to predict based on one feature, that is the date and the alcohol cells, and thereby it is a recurrent neural network that is valid for a sequential data. For other dataset, our neural network will vary quite a lot. For that, we'll come up with one more project, something in the future. I'll keep that for a later video. Well, thank you and goodbye. I'll see you in the next one.